So, our next presentation is from Schloh von Bennewitz. He is a computer scientist specializing in embedded circuits, and he's the chairman of Novel Circuits, where he produces cybersecure electronic devices while contributing to the open source development communities. Michael teaches hardware security and fosters electronics enthusiasts at the Badge Clinic. Hence, the Kicon badge that he and his team have designed. Together with a team of hardware hackers, they solve crime and protect Gotham from... he has produced the Kicon electronic badge to help celebrate technology. Please give a warm welcome to Michael.
Okay, yeah, so this is my first slide. This is about the Kicon electronic badge. This is my last slide. I don't like slides very much, so we're going to switch to dynamic mode and just do everything using cameras, things like that. So we'll just say, like here, for example, the dynamic talk. Is that okay with you? All right. So you may have met me out in the social area. We had this set up with the camera, and you may have, hopefully everyone, received one badge, one electronic badge that you can see on the screen. It was made for Kicon, but it is a generational evolution. We've been working on the circuits and the different materials for a few years. So it is a derivation from the HOPE badge, Hackers on Planet Earth, which was a derivation from Hacking in Parallel. So it's not an original. All right, and this will be a little disorganized because I'm quite burned out, and we're going to do this very dynamic. So I think you can see this well enough. It's always a question if the lighting... Okay, we'll just get started with this. Few photos first of all. This is how the badge looks in the package. You may have received one at the door. I hope you did. There is... so I have this main battery is really weak. And so you have a lanyard, as you can see, with a nice leather decoration. This is faux, what do you call this, leatherette or faux leather? It's PU, so polyurethane leather. It's not real. And the badge is inside the bag, of course. Then you've got some things resembling a user manual. If you open this up, you saw it's exactly one page folded, so very little information. We still call it a user guide, badge guide, I guess a miniaturized version. And then you've got your badge inside there. That's the next photo. So that's basically what you receive. And once you remove the badge, it looks like this. There are just a couple parts that you didn't receive, like these dust covers made from silicon, which we ran out of. Then the last, or the second to last photo, the back of your badge, it looks like this under the covers. This is sometimes important to know what's under the covers. This is the appearance when you remove it from the bag. And I wasn't sure how to do this. The next time I'm going to just include a label, this metallic label that you have to apply by yourself, because if I do it for you, then you don't realize what's underneath the label, right? So you do get a fine polyamide made with KiCad, of course, NFC loop. It resonates 13.56 megahertz, of course, as it should. And this is the way the back of the badge looks before the label is applied. Let's see if we have more photos. Yeah, just some. I made some close-ups. Anyway, so those are all of the photos, and we can get started looking at some of the materials and later on the circuits as well. The schematics, everything is online. Good, so let's see. How should I organize this? I think the very first question that people have is, what does it do? How do I use it? Right, so for that, I need either one or two badges. So obviously, let's zoom in just a bit. And yeah, this lighting is not optimal, but because you can't see the black plastic on the background. We'll do our best. So there is a on-off. Yeah, no, it's usually that when there's too much light, forget it. So there is an on-off button, which if I just tilt it just enough, you can see the debossed into the polycarbonate enclosure, the on and off switch, and then I'll just do this with one hand, I guess. Turn that on, and it should, whoops, oh, this is this one that, this is one that's, the battery is dead on this one. So I will use this one here, which the battery, I've just charged it. And so that's kind of what you get. I'm not sure if you can see that so well. It is brilliant. It is kind of, I'll just put this up here. So you have some lights that turn on. Thank you. Somebody just zapped me because I felt it, the vibration. We'll get to that in a minute. So that's what happens after you turn it on using the on-off switch in the back. You can press on the middle button, which the second button of the middle, I guess, what do you call this? Second from the right. And this will increase the intensity. So as you can see, it's getting very bright, and it does wrap around, so then it goes off completely, and then it starts getting bright again. If you depress this button, is button number 3 on the schematic, for a long time, so you do a long press, it changes to the next animation sequence. This one is a very nice, can you see that? Yeah, it's a very nice rainbow style. This is my favorite one. It's the third one. Depress it long again, and then it switches again. All right, so now you know what the button number 3 does. The button number 1 and 2, they're not very well used, but mostly made for you to reassign when you reflash the firmware, however you like it. The second button decreases the intensity as the third button increases it, and the second button decreases it. You get the idea. The first button changes the animation sequence, similar to the long press of the third button. So the first 3 buttons, now you know, it's mostly to control the lights and the colors, the animation sequence, and the intensity. The last button, if I press it, nothing will happen because it's firing an infrared signal, and you can't see that with your eyes. So you press on there, and it fires an infrared signal. I do want to ask for your participation. If you have a badge with you and it's in your bag and it's easy to access, then in 5 minutes or so, be wearing it, and we'll do a Pixel Mob style Taylor Swift concert. I'm not going to dance, but I will try to create some Pixel Mob style animations in the room. We've never done this before, so it could go very wrong. It's a high risk demonstration, and so we'll see if I can zap all of you, and you will feel your badge vibrating when that happens. When a badge receives infrared, it vibrates and has a distinctive animation telling you you just got laser tag shot, or don't like saying shot, it's zapped, right? So that's basically the lights. And I feel like we need to go faster. There's so many features. What else can I say at this point? So those are all of the buttons. The buttons do nothing else in the stock firmware. As it leaves the factory, the program chip has an application running, and you basically know now most of what it does. A demonstration to show let's see if I can zoom this better. Well, there is a gas sensor as well here at the top. There's basically 2 holes, and you're wondering, well, why are there holes in the polycarbonate enclosure? It's to let gas in and out so that the sensor can work, and to let infrared signals in and out to not have to pass through an extra layer of material. And it's an injection molded enclosure. It's very nice, designed by Alex in Munich. Couldn't be here today because he couldn't get vacation time. Poor Alex. Then I can show the NFC properties and feature. That is easy with a phone. This is going to be, though, tough with one hand. Let's see how to do this. Move this up a bit so we have more distance. And put my phone here. So, I don't know how. I know. That's very nice. Can you hold this? Oh, hold that. That's even better. Perfect. Thank you. What's your name? Clem. Thanks, Clem. Okay, so we have a badge and we have a phone, right? And so I'm going to use this one because I know what's on here. So, and you can see the loop as well. So it doesn't even need to be turned on. So you can do this with a dead battery. And I'm basically going to, phone needs to be turned on, right? It needs to be turned on. Just rub this over the screen. And it's asking me, what would I like to do? Now, Sam, what do you think is encoded on the badge if you're looking at this and seeing that it's recommending to run Chromium?
I think it's a Rickroll.
It's a URI, exactly. So I'm just going to, this is in German, nur einmal. So I'm just going to once open Chromium to the URL that, and the network is a bit, yeah, okay, it's working. So as you can see, this URL is encoded on the badge, and it's the Kicon program, the agenda. So that's kind of useful. You can do this by yourself, encode things on your own. Then you need an application to do that. All right, so this is the one I like to use. I think most people use NFC tools. You see that orange circle? That's the one you want to install. It's a nice application. And so I'll run that. NFC tag. Okay, and I can read what's on here. So that's the first thing that you may want to know. By the way, this is about the distance. It's 1 centimeter, 1.5 maybe. And this is telling me that it has a URL and the data set. And, well, it's not going to focus that quickly. I can write something else. I think I'll skip that presentation, but you can put a lot of data sets on this one EEPROM that you have. I think it's 4 kilobits. And so you can do things like you can add a, look at all of these things, node file information. You can add a emergency information. I can say my blood type is B+, and I am an organ donor, and you can do all of these crazy things and put that on your badge, okay? Now, we can get into NFC, talk about a lot of things. It's not a reader, it's a tag type 5, but to keep things short for this presentation, we'll end NFC with that. Thank you, Clem. Sem, right? Clem, okay, sorry. Great job, Glenn, thank you. And that was a demonstration of NFC. Okay, so we've done lights, animation, we've done infrared, NFC. I pointed out the gas sensor, which is SGP30 from Switzerland, the Sensirion brand. And so that's going to be difficult to fit into this presentation. This is kind of a user level explanation, and later we'll get to the circuits and the schematics and so on. This is how the NFC loops look when they're manufactured with polyimide material. We're trying to understand if we want, actually this one is PET, this one is polyimide. And yeah, there's been some talk about introducing flex PCB configuration in KiCad. I find it works just fine, pretending it's FR4, normal substrate. So that's what we made with KiCad, and then we put that on the back, as you can see, and snake it through. And that's one thing I may demonstrate now, is to show you how to open your device so that when you remove the enclosure, that you're not destroying, or not destroying, but removing wires or bending things improperly. And so this is, I'll try to do this quickly. So I think you can still hear me. I'm going to just use a screwdriver, and this may help you understand where the different wires are as you are, hopefully you do this at home, you take it apart as every hacker would, right? So those 2 screws are done. You have 4 screws to remove. And then that one is the last screw. Our screws are loose. And this is the trick now, how how to remove the enclosure so that you're not messing up some of the parts inside. I do recommend you kind of look in the edge and just slightly take it off like that. The camera's probably not going to capture the different things inside, but what you'll probably find, this is the difficult part. I'm going to try to get it to show. It's not going to do that. Yeah, there you see that little cable there. You want to avoid unplugging that. That's the polyimide antenna that's going to the back. And then you want to do that again? Okay, and so we do have a vibration motor as well that's usually mounted onto the enclosure inside your badge, so that's going to be a difficult thing for you as well. All right, so that's the demonstration of how to remove the enclosure. Oh, the other thing you may like to know is this one has a display, but these buttons do fall out. So you want to be doing this on a table. Don't do this on the train or where you don't have a safe area and can pick up parts off the ground. All right, so that was the demonstration of removing the enclosure. Thank you, Seth. What should we do now? I'm going to ask for questions in case we want to ask about user-level questions before we get to the bill of materials and schematics and different things like that. Are there any questions about how to use your badge? Okay, then if you're wearing your badge, then we're going to see how strong these vibration motors work, and I'm just going to do a little Taylor Swift here now. So we're going to see how far back. Yeah, I'm getting all the way to the back. I believe this is not going all the way there unless I aim carefully. And yeah, I got every person in the room. And if you want to shoot back now, you can score some points, I believe. And you can see what it does. It basically turns yellow. Right. So now you're welcome to zap one another, to get to know your neighbors especially well. You need to zap them and generate some high vibration contact with your neighbors. That sounds a little bit perverse, but okay. So now you know how the vibration motor works, and that's more or less all of the funnest features from a user standpoint. There is a user manual in some of the packages. We don't have them for Kicon, but as you can see, there are actually more features than that, but that's kind of enough to help get you started. There's a story behind the packaging and what is included and what isn't. If you want to know what a typical package, what we wanted to deliver here at Kicon, this is how that looks. And it is very comprehensive. It has the package includes. Is it going to work? Yeah. Package includes a very nice USB media with dual interface, Type C and Type A. It includes extra parts, screws, bumper feet, which we didn't get here, dust covers, a hex wrench to be able to immediately disassemble your badge, of course the lanyard, an antenna, a larger battery, and then of course the packaging and a user manual. And we had lots of problems with sponsorship, and we had massive losses and ran out of money, so all of these things were not included in the Bochum package, unfortunately, and I apologize. Who knows, maybe this will work for Shenzhen, but it's unclear. All right, so now we can, I think, move on. Unless there's questions, we can move on to some of the other things. And I don't see any questions, so one question.
Yeah, I noticed some slightly dim LED facing inwards to the black cover side. What is that doing?
Yes, let's take a look at that. Good question. And that is, let's see. So I believe you're talking about, it's just over here. And as usual, this is not so clear. You don't see the light, but it is in between, I guess, the, 1, 2, 3, between the third and fourth LED on the edge. And if you look at your badge as it's turned on and it's illuminated, if your battery isn't dead yet, you have to charge them overnight. That's another problem we had. This is a standard LED. It's a 1206 package size because most of the ones that we could find easily available that are reverse facing were 1206. We didn't search too long on that. And there is a hole, as you can tell, it's cut through the PCB so that you can shine this backwards. You can't mount it on the other side. That's not an option, but you are mounting a standard LED on top like this, or you're simply reversing it, turning it over. You can use any 1206 LED and just simply reverse it. They usually have enough metal on the edge that that works. And the reason for this mini feature is that we'd like to encourage people to at least learn to solder SMD a little bit. And this is so, it's not, I don't want to say well made, but it's created in a manner that it's ready to use out of the box, no soldering necessary. And we like to make that statement as an encouragement, start using your badge, and then slip in a few, oh, by the way, you can modify your badge. You can hack your badge in here. Look how easy it is to remove a LED. You see, so that's kind of the baby steps method to get kids and adults who are into soldering. So that's more or less the answer to your question. And it's actually some cases like this one, you can see that we did not reverse it out at the factory, and in this one we did, so it's kind of hit and miss. I'm not sure what the best choice is there. Any more questions, or shall we look at circuits? One question.
Is the 6-pin header on the left SAO compatible?
Yes, it is. All of the 6 pins are populated except for I think the furthest right are GPIO pins in the SAO simple add-on standard. You find it at Hackaday very easily. The first 2 pins, it's well labeled on the back, so instead of guessing, you see the camera, yeah. All right, so looking at the front, the first 2 pins on the left are power at the top and ground at the bottom. In the middle, you have your I2C pins, your clock and your data. And then on the right, they are labeled on the silk screen, GPIO 1 and 2, but I believe they're not routed. There are not just the SAO two furthest pins not routed, quite a bunch of stuff is not routed. I just couldn't do it with 2 layers. And for example, there is well, no, I take that back. The microphone is routed. It's just not populated usually. There is a UFL connector over here. It's not populated either. And if you do populate it, it's not routed. So then you have to use jumper wires to connect the UFL. We had a little extra board space. And then I thought, okay, I can still route it, maybe 4 layers. And there are a few other things, but I'm kind of forgetting where they are, unrouted. Oh yeah, there is a RF switch as well up here somewhere. You can see 2 unrouted, I'm sorry, the unpopulated parts, and they are EPROMs. There's an identical EPROM pad here. I'm not sure if I should use a laser. This may be easier. So this EPROM, this is the NFC EPROM that's giving you your NFC transceiver and your reception, your transmission, and an EPROM of 4 kilobits inside as well. There are 2 more footprints. You can put identical parts on there, and then you somehow have to switch from one to the next because obviously there's only 1 antenna to serve these transceivers. And so we put I don't even know where it is. It's so small. It's like 1 millimeter RF switch somewhere. I really can't find it anymore with my eyes. It might be this one, U12, I believe. It's extremely small. And so these things are not populated because they're new features and we just haven't tested them enough. And I'm quite sure that it wouldn't work. We would need a couple months of testing. So there are a lot of things, and this, going back to what's not routed, like the UFL connector is not routed. This RF switch, I couldn't find a way to route that either. So that's another reason it's not populated. Let's see, so I'm not sure, kind of half hour, I guess, what we have still, right? Any other questions? Or we take a look at the bill of materials. I don't like to abbreviate that when I'm being recorded. Bill of materials. So we can make this a little bigger, maybe. Does that work? Yeah, we'll just run through this. There's some passives, obviously. We're not going to talk about the passives and the resistors. They're just basic stuff. There's some diodes. These are the WS2812. There's 16 of them, and there's nothing special about it. They're called neopixels, I think popularized at Adafruit. So a lot of hackers and hacker communities use a lot of them. Clement's wonderful EMF design uses WS2812s. This is the one we talked about, I think, is the reverse mounted. Is it? No, it's not, because, well, I told you it's 1206. Now, that may be a failure of my memory because it's the only white one. Okay, so we have other LEDs here, and these are mostly, you're wondering why are there so many of them? The battery, it does have quite a nice battery charging power management circuit. It's with a microchip, MCP 17381, I believe, and it can only charge one cell, but it does a very good job at it, and it illuminates these different LEDs according to its charging, or it's fully charged, you get the idea. Or if there's a failure state. Anyway, that's what these all these LEDs are doing. The Schottky, that's a diode, and then I guess we can move over a little, yeah. And then the rest of the bill of materials is here. What else is interesting? Some transistors for just making it switch on and off without any spikes. We do have a transistor, it's this one here, for the power, for the vibration motor. And I'm going to say this fast, but it's something that I care a lot about, and we have a problem with this. Right now, it's hot wired to the MCU pin. What that means is that your microcontroller is turning it on and off, 1 or 0, high or low. It's sending a 3-volt signal directly to the motor, and that signal is driving the motor. It's not the correct way to drive motors. You shouldn't do that. And the reason that we're not using this transistor, which is the correct way to do that, is that this interferes with the power or something, and your badge will freeze, restart. It will stop working. If we use this transistor, it's a problem. I really need your help to solve this. We'll take a look at the circuit later if we have time. And what? You think that's a ground balance? That's one of, I didn't test that. I tested 15 things. I've been working on this for like 3 months. I will look that up. So I can type in ground bounce into Google, right?
If you don't have a ground plane and you're running lots of wires, you may have enough resistance there when that transistor turns on. There's going to be an immediate current spike to try to drive the motor. Right. The ground will raise up, and when it happens, it may hang the micro. It's been done many times before.
Okay, so for everyone listening at home, that was Wayne giving us excellent advice. Thank you very much. He said it's a ground bounce, and so we have to check that out later. I assume chances are high that that's because we've tried everything else. Anyway, so not to get too stuck on the transistor logic, but what is this here now? Screen is a little bit... I'm actually, oh yeah, this is the IRM it's just kind of off the screen, but that's the receiver, the IR infrared receiver. We've got the MCU. These are the important parts, shaded in blue, all of the active parts. And the MCU is a ESP32C3, as you can tell. So that's quite nice because it's RISC instruction set architecture. It's a very small, kind of weak chip, so there's some disadvantages as well. We ran out of MCU pins, outputs, inputs, and so we overloaded the USB pins. Shouldn't do that either. Basically, everything we do, you shouldn't do that at home, but we do it anyway. And the reason, well, of course, we wanted to have a display with SPI, 4 wires. We need 4 inputs for that, plus the LCD, plus the dimming, and then we wanted the power, the motor, the vibration motor, more inputs. So we ran out, and what that meant was we were going to have to reduce features or overload something already being used, like USB. So we decided to overload the USB because the intended use is a wearable. You're walking around, it's mobile, you're drawing from battery source of energy, and you don't have this attached to your computer with a USB connector, which is supported, but then you are not allowed to use 2 of the buttons. All right, so that's the story behind the MCU, basically. It's an ESP32C3. Then we've got some power things. That's the battery charging chip. that does the LEDs as well. We've got a fuel gauge, which, I mean, I don't have to explain what it does, but the question is, we don't have a display in the package, the Kicon package. We ran out of money. And so usually you look on your display, you've got that little, fuel gauge style graphic. And on a badge that doesn't have a display is kind of a question. Do we need a fuel gauge, yes or no? And we're depending on you, me, everyone, to find an application that's really fun to use and design that uses the fuel gauge, because it is in your badge. Your badge is high-end. It has a lot of parts. So I recommend exploring some of these things. Here is the NFC chip. There is the SGP30. That's the TVOC. That's a gas sensor, right? It's actually a total volatile organic compound sensor. So you can sense methane, nitrogen, I believe quite a lot of things, carbon monoxide with this. You just have, I'm not totally sure about it, but you can do more than what we do with it. What we do in the stock firmware application, we're trying to measure a threshold of carbon dioxide concentration, which basically means if you're in a nightclub with a lot of dancers, people breathing and breathing, you may want to know that you're in a poorly ventilated area, just for the contagion of airborne pathogens is kind of the background behind this. But it's just a demonstration application. We can do a lot more with the chip. What's the question? Right. Alcohol is a carbon chain, right? So you can measure it with this total volatile organic compounds. So that it could be possible to do like a bar type alcohol. How do you call this? A police style alcohol breathalyzer. Thank you. And I really don't know if it's, I hope you try it. I hope you try it. If you love drinking, then make sure you're using your badge responsibly. Oh, and drink responsibly as well. Okay, so there's that. That's the gas sensor, TVOC. So we have a flash SPI EEPROM, and unfortunately, this is populated, but I got the circuit wrong. It's not working. I'll just leave it at that. I forgot to populate some of the resistors, and I used a different flash chip than this one. This is a CAT 256. I believe I used a 3C9003 chip. It's flash, it's EEPROM just as well, but the pin assignments are different. So this one is not populated. This is an extender, an I/O extender, which is commonly used with the MCU, which has very few pins. So this allows you to have more inputs and outputs. Whoops, this one. We're not, but it's not populated for a couple different reasons. Anyway, and this is a nice chip here. This is a ATECC 608A. This is a secure element. So that makes your badge qualify as a crypto-secure electronic device, I believe, because you can you have 16 slots in this secure element, and you can destroy the filament. You can actually blow fuses in each of these specific 16 slots to make sure that the key you've generated stays in that chip and can never leave the chip through those lines, right? So it's a specialized chip. It's very nice. That's this secure element. And then the RF switch, as I talked about before, it's not routed. With 2 layers, I couldn't do it. And it's kind of a late addition that may stay or may not. It's a hacker device, so we can not populate things and just forget to tell people they're not working yet. Good. So we have 2 crystals. One is populated. That's the 40 megahertz, the one that you always need for most microcontrollers. That's the one that's usually in use. And this one, at 32 kilohertz, is used if you're in sleep mode and you want to keep your clock working, so that, for example, your TLS stack, your security on the Wi-Fi still works when you come up out of sleep, things like that. Then you want this clock, but we don't populate it because we're reusing the pins for other things. All right, so that's the reason. And then I think we have some less interesting things here, like switches, the SAO connector. Is there anything interesting here? I believe there's not. And by the way, we are including with your badge a circuit board. So in case you were wondering. All right. Oh, the other thing, speaking of circuit boards, and this is not a joke, there are a few of these available over in the social area. You can just pick one up, take it, because it makes it very easy to see the designators, and there's no chips covering up parts that you may be interested in. So you can pick up a bare board PCB in the social area. Good. And then I believe this is interesting and important, but we're going to go really fast. These are all of the things that are not KiCad relevant, like an enclosure. That's more like FreeCAD, right? Although Alex used Fusion to make it. So, so we have some dust caps made of silicon. The vibration motor is probably, there may be, well, who knows, maybe they use, I don't know if there's a PCB inside, probably. There is a PCB in the, if I can find it, in the battery. Where's the battery? Does anyone see it? Battery, I don't know. Over here? Did I miss it? Oh yeah, here. There's a few things here that were off the screen. So right, the batteries, if you don't know much about lithium ion or lithium polymer, they need some extra help, you know, like battery protection for over voltage or over temperature. They can measure the temperature with the resistors. So there's a PCB inside there. We hope that it was made with a KiCad, but it's out of our control. We would pay more money in order to supply our own design. And so anyway, we've got a lot of things here. We usually like to enclose all of them, although some of these prices are difficult to justify. So this does not cost this much. That's incorrect. And then other things like the enclosure will just, how much did, so I wrote €5 for the enclosure. It's more like 5,000. All right, if you make one enclosure, you need €5,000 because you need to route the steel mold, right? So it's like, how do you calculate that? So this is not very accurate, but these things, according to, I mean, in my opinion, like the PET label on the back, which is sometimes quite fine and tells a big story of, for example, what is on your badge. You can tell that there's LED, USB, you kind of remember some of the top features. And then some of these are rather nicely made with colors and so on. This is a good one. We did for Hope. This was our first try at CMYK on a metallic PET label. But so anyway, this is kind of, these things matter to me. I don't know if it matters to you, but we put them in the bill of materials alongside all of the SMT chips just because for completeness and, well, for a number of different reasons. So that's the entire bill of materials. And right, so the next thing we can do is take a look at some of the circuits.
Quick question, Michael. Are these circuits published? Where can people look at them?
Yes, the circuits are published. So I'm going to answer this question with the camera because what I recommend, lots of people want to see the information online, for example, and we unfortunately couldn't enclose very comprehensive user manuals. So the one that you received does not have links and things, but the normal one does have links on there. So there's a lot of shade here. It's not, and what I recommend, I mean, of course, you can make a photo of the screen now. So this is kind of ridiculous, but you can take a look at this user manual, the very comprehensive one, in the social area. If you know you're going to want to inspect the schematic and try to offer us help with things like the vibration motor and get in touch with us, and you know, there's like there's a QR code. And that's great for asking questions. It's a very active group. Unfortunately, this is a Signal group, Signal is not, the designers and developers do not intend for group communication. They intend for person-to-person communication. So when you join the group, you don't get a history of all of the questions answered before. It's a bit of a shame, but it's actually a design decision. It's actually good for us for security reasons. So what you'll have to do after joining the group is ask the question that's been repeated 4 or 5 times. And we all understand that that's perfectly fine. I'm mentioning this because it's not obvious, but ask your question as if it has never been asked before. Join the group, it's very active, and you'll get an answer about batteries, displays. Everyone wants to know what the correct display is. It is for Hope. We're not going to have the resources to do Hope, HIP, Kicon, and the next one is in Atlanta, is TabConf. It's a bit difficult to juggle these things around, so it's not very well organized. It's not a generic group that everyone uses. This one is called Hope, and the next one is something else. I apologize for that. But anyway, there is information available. So I believe that answers your question. I mean, it's not what you wanted. You wanted to hear the website with the WebGL, rotating animation and everything else, the interactive, Ruby on Rails, wonderful website. We don't have that. We don't have, unless you want to provide that to us, right? We don't have the resources. Okay, so that was a long answer to that question. Are there any other questions, or shall we take a look at the schematics? Question? Okay.
Just a short question. What is we?
Yeah. I don't know. Next question. No. Okay, in my opinion, so the genesis of this badge was in Berlin at a CCC event called Hacking in Parallel. And we is Tito Klassen, it's a bunch of people. Alex made the enclosure, me. It's Osh Park, who has pledged for a very generous pledge of boards. It's PCBWay, who produced the blackboards and contributed chips. It is Thomas, Soren. It's a lot of people just 2 days ago, assembled in the Skunk Force offices. So Skunk Force is a contributor as well. Tabea, a lot of people as we. I'm just going to end it there because it's going to take too long to go through the dozens of names. I apologize. It's a Beagle Board Foundation is on our side. Signal, of course, as you see, Signal, as you saw in the manual, Signal Foundation, and quite a few others. Parity Networks is another good one. And then all of the, like the St. John's University in New York. We've got the ETI establishment in Berlin that have offered us space and area and warehousing. So I'm sorry for making it a long answer, but there's a lot of people involved, and it's the difficult question to answer. All right, so we have just a few minutes. I think, we can, this is probably not worth looking at. I'm just going to show the main, this is the MCU. This is kind of the way our schematic looks. So that's the vibration motor down below, and then we'll look at the layout, and that's all we'll be able to do. I'm not a Windows user, so this is it's gonna look like, oh, it's his first time using KiCad. No, it's just that all of the I'm not a Windows user. And I don't know how other people do things. I'm always doing like, this is the level, where the hole through the polycarbonate enclosure comes in is at this position. And if you look on the back, it's not exactly lined up with the connector because it should be right here, but there's a screw there. So I get all these notes in the layout. And I can zoom out a little if I can figure Windows out. I don't know if this is, how do you do F4 in Windows? There we go. So yeah, and these are some of the displays and the battery sizes that we've taken a look at and decided which one to use. So anyway, that's the layout. The schematic was on the other side. And I think we need to get to questions now. You can ask about the materials. You can ask about the history, about the schematics. Are there any questions about the use cases and how the lights turn on and off? It's time for questions, and Seth will help you with the microphone, or I will ask you questions, so be careful.
Yes, I have a question. Why do you give it to us for free?
Well, that's kind of, I don't know if that's a personal thing. I prefer distributing things free of charge. Most people that should be scientists and study technology are not doing so because they're not purchasing Arduinos and they're not purchasing Raspberry Pis, and it's also complicated. They better stick with whatever their lifestyle is, and you hand them something that's very fun to use, and then you explain just a couple things. There's an LED you can reverse, and that's how you get kids involved in science and technology. So that's the short answer to your question. Right. Obviously, there are other options. We could charge at the door or have then Seth would have more work to do to put an extra purchase button on it would just, so there are other options. If you believe there's a better option, then you should be the one managing the distribution, and you're welcome to do so. Anybody is welcome to join the team in this kind of half sloppy manner. As you can tell, over generations and evolution of this design, different people get involved, and so it's a lot of fun that way, like Skunk Force and Tabea and the people who were helping over there do the assembly. There was 5 of us. We had a nice dinner. It was nice, wasn't it, Thomas? Yeah, he's in the crowd. So anyway, any other questions? I'm warning you, if you don't ask questions, I'm going to ask you a question. You're not going to like the question.
Very often, if you're at conferences, the badge is used to say Michael or Michael, or have its personal identification, showing a name or whatever. Can we use this or make use of it somehow?
So I believe you can, and maybe you can see what happens when you turn the display on. This display is, it's not a name, but you get the idea. It should be possible. Now, these badges are quite thick. I believe what you want in this type of a name tag style use case, you want an extremely thin badge with maybe a magnetic clasp instead of a thing that hangs down. But there is an option to turn these badges into real name tags. Does that answer your question? Right, and then this follows into many other questions, obviously, like what is the correct display? How do I plug it in? How do I drive it? Is there a software driver? What's the manufacturer? And those things won't fit into, so you do have to come over to me in the social area or join the Signal group if you forget and think about it later. Like, yeah, so that's my answer to your question. Any last questions? So this is my question for you. This is what we need to solve. This is a circuit for the vibration motor, and we're hot wiring it to the MCU, which is really bad. If you have experience with transistors, with NPN transistors, P channels, N channels, then we're doing something wrong, but nobody can figure out. Even Clement looked at this and couldn't see an obvious mistake. So this is my question for you. Come to the back there after the talk is over, and if you think you can help, then this is a great way to instantly turbo boost our next evolution of the badge, and which will be in Atlanta. Okay, so that's all for me. Thank you.
Thank you, Michael.